In this lesson, we'll lightweight a two-part bracket using the periodic lattice block. We'll discuss both a TPMS unit cell as well as a graph unit cell, and practice cell mapping across a part. Download the starter file below to begin. In this starter file, you'll see an embedded part. If you don't see the part in your viewing window, select the block and use the hotkey Z to zoom to fit your viewing window. Before we begin our workflow, hovering over this part, we see that we can select edges and faces. This is a CAD part, so we'll first have to convert to implicit bodies and topology's native geometry. We'll start in the Utilities tab under Conversion, and we'll pull an implicit body from CAD body block into our notebook. This is where we'll define the inner body. We can copy using Ctrl-C and paste a second block of the same type into our notebook using Ctrl-V. Now let's open the block details of our part, and under Properties, we can pull our Body 0 and Body 1 into our CAD body inputs. Selecting either of these blocks and isolating using the hotkey I, we can view which part of the bracket we're defining. We see that this first block is the inner body of the bracket, so I'll right-click and make this a variable called inner body. Then I'll isolate the next block using I, and I'll make this a variable, calling it outer body. Now that we've defined both the inner and the outer bodies, I also want to define the entire bracket. Under our Modeling tab, in the Boolean section, I'll add a Boolean union block to my notebook. For our implicit body list, I'll pull in both our inner body and our outer body, isolate using I, and I see that I've now defined our entire bracket. I'll right-click to make this a variable and call it entire bracket. To clean up my notebook, I can collapse each of these blocks using the spacebar. Now let's explore latticing using graph-based unit cells. Click into the graph-based lattice section to drop this white line, which is where all of our new blocks will go. Let's begin by adding our periodic lattice block into this section. I'll go to our Lattices tab, and under Lattice, add this block to our notebook. In this block, we see that we have our two main inputs, a unit cell and a cell map. Let's begin by adding our unit cell. Under Unit Cells, I'll add a graph unit cell to our notebook. In this new block, I'll choose our unit cell type, body-centered cubic, and I can change our orientation. If I zoom to fit using Z, I see that this is our individual unit cell that will map across our cell map. Under Cell Maps, I'll add a rectangular cell map to our notebook. And for our volume input, I'll use our inner body because this is the body that I want to lattice. I'll set a cell size, 30 millimeters cubed. And if needed, I could set a frame where I could define my origin and X and Y axes for rotation. Now that we've defined both our unit cell and our cell map, we can add them to our periodic lattice block. We see that this first parameter has updated to thickness, since that's the parameter associated with our graph unit cell. I'll give this unit cell a thickness of 5 millimeters and press Enter. If I zoom to fit using the hotkey Z, I see that we've created this periodic lattice across the span of our inner body. Now, to trim the excess from the outside of this body, I'll add a Boolean intersect block, which can be found in our Modeling tab. I'll intersect this new periodic lattice block, as well as our initial inner body. If I isolate using the hotkey I see that we've now trimmed this lattice to only fit within the bounds of our inner body. I'll right-click and make this a variable called graph lattice. Say that instead of a graph unit cell, I wanted to use a walled TPMS unit cell. Let's drop our line into our walled TPMS section and add another periodic lattice block to our notebook. For our unit cell, we'll use a walled TPMS and we'll select a gyroid infill. We can add this to our periodic lattice block. Now let's create our cell map. In comparison to our rectangular cell map that we created earlier, let's try making a cylindrical cell map that aligns with this hole in our inner bracket. Under our cell maps in our Lattices tab, add a cylindrical cell map block to your notebook. In our volume, we can double-click and choose our inner body variable. And let's set our cell radius as 30 millimeters and a cell height as 30 as well. We'll make our arc count 15 and view our results. We see that this isn't lined up with the hole like we would like. So let's adjust our frame. We can double-click in our frame input and add our frame. For our origin, we can pull this gimbal to the center of our hole. And we can adjust our X and Y axes as needed. If I view this new frame, I see that we've created this cylindrical cell map that's aligned with our part. Our cell radius is 30 millimeters. Our cell height is 30 millimeters as well. And we have an arc count of 15 arcs going around this cell map. Let's pull this cell map into our periodic lattice. And we'll give our walled TPMS an approximate thickness of 5 millimeters. Here we can see the periodic lattice that we've created along this cell map in comparison to our rectangular periodic lattice from before. Let's add a Boolean intersect block to trim this up. And we'll intersect this periodic lattice with our inner body. We can right-click and make this a variable called walled TPMS. Using the spacebar, I'll collapse both of these variables, and we can move on to creating our final body. Here, we'll add a Boolean union block to union one of our lattices with our outer body. It's good practice to add a blend radius to strengthen the connections between the lattice and the outer frame, as well as decrease stresses in these areas. I'll add a radius of 5 and isolate this using I. Often when adding these blend radii, we see these extensions of our structures. We can trim these the same way we did with our periodic lattices, using a Boolean intersect block. And we'll intersect our Boolean union with our entire bracket that we made in our geometry section. Now we've trimmed off any excess, and we have our final lightweighted part. To view this part with our cylindrically mapped walled TPMS, we can just pull that in place of our graph lattice.